Good afternoon, everyone. My name is Teillard. I'm thankful to ATF for inviting me to this session, and also a bit intimidated to give the first presentation of the session that focus on positive contributions of livestock to biodiversity and quantitative assessments. I thought I would start the very first presentation by giving the big picture of livestock effects on biodiversity. The big picture has a negative side, the fact that livestock contributes to all 5 drivers of global biodiversity loss: habitat change, pollution, climate change, invasive species, and overexploitation. Actually, within each of those drivers, there are more specific pressures of livestock on biodiversity. So for habitat change, for example, it ranges from habitat destruction, deforestation, for instance, to habitat degradation, some practices having detrimental effects. But there's also the positive side. When livestock systems are managed sustainably, probably more than any other sectors, agriculture or any other sectors, they can be of very high nature value. They can boost plant species richness in grassland, maintaining grassland habitats that are of high quality and that host a unique biodiversity, and contributing to the health of those grassland ecosystems and providing a range of ecosystem services. What's interesting is that most of those specific pressures, they can actually turn into benefits. For example, you can switch from habitat degradation to habitat restoration, and that will depend on the context and on management practices. So how to assess all those effects? Where I see 3 main challenges. The first one is that there is a large diversity of impacts, as I just described, ranging from negative impacts to positive impacts. The second challenge is that livestock supply chains are complex, they're globalized, and so you have to consider both on-farm and off-farm impacts. And the third challenge is not specific to livestock, and it's the fact that biodiversity is intrinsically complex. And unlike other environmental criteria, where there is a common unit, you can express climate change in CO2 equivalent or nutrient pollution in kilogram of nitrogen, for example, well, such common currency doesn't exist for biodiversity. There are several initiatives that try to tackle this challenge of biodiversity assessment in the livestock sector. One of them was within the FAO-EAAAP partnership, and it led to the publication last summer of guidelines for the quantitative assessment of livestock impact on biodiversity. This document was developed by a group of multidisciplinary and international experts. It reflects a consensus at sector level. That's very much how the LEAP partnership works. And it went through a multi-step process of review. The scope of the document is quite ambitious. It seeks to be relevant from local to global scale, to consider all those impacts across the supply chain, from upstream to downstream of the farm, to be able to consider positive and negative impacts of livestock on biodiversity, and to be relevant to a diversity of objectives, of users, of regions, and of production systems. One of the ways the LEAP guidelines respond to this ambitious scope is by proposing 2 methodological avenues for biodiversity assessment. The first one is life cycle assessment, LCA, which is adapted to assessments at larger scales and very much adapted to assessments of impacts across globalized supply chains. It's suitable for comparing baseline and scenario and to revealing hotspots of impacts along the chain or geographically. One limitation of LCA is in its scope. The fact that current LCA methods for biodiversity, they focus on impacts through land use. They focus on a few biodiversity metrics, such as species abundance or species extinction, and they don't do a very good job at the moment to reflect positive impacts. The second avenue is ecological indicators, which have been used at all scales, but a lot at small scales, field, farm, the landscape. those are suitable to actually customize assessment depending on conservation priorities and through stakeholder engagement. One limitation of ecological indicators is that often they require a lot of time and expertise, and they're constrained by important data collection efforts. So just a few words on those two methodological avenues and how they're dealt with in the LEAP guidelines document. On ecological indicators, the document doesn't give a prescriptive list of indicators, but instead it gives a non-prescriptive list of 50 indicators that can be used and that the user can pick from, along with detailed guidelines for how they might be selected and applied. There are 7 categories for those indicators, and you can see that 3 of those reflect positive impacts: wildlife conservation, habitat protection, and conservation at the landscape scale, while the other 4 are more related to negative impacts: habitat change, pollution, off-farm impacts, and invasive species. And then there is a checklist that ensures that the procedure of assessment using those ecological indicators is robust. It's, for example, about defining the goal and the scope of the assessment, making sure that regulatory constraints on biodiversity are considered, but that the point of view of key stakeholders is also considered in defining conservation priorities, in selecting the indicators. The checklist also ensures that biodiversity is monitored over time, that data quality is ensured, and that results are communicated transparently. On LCA, well, LCA is a standardized tool which is very much decision-oriented, and it is widely used for other environmental criteria than biodiversity, greenhouse gas emissions in particular. It always follows those 3 main steps. The first one being the definition of the goal and the scope of the assessment. Then life cycle inventory, so the collection of inventory data. And in the case of biodiversity, those inventory data are quite simple. They are the area and the location of different land use categories. In that case, 3 intensity classes of pastures and of crops. And the last step is life cycle impact assessment, and it's about translating those inventory data, land use in that case, into an impact on biodiversity. And in the LEAP guidelines document, there are several methods that are reviewed for doing that translation. One of them is recommended by default, one by Chowdhury, and it turns those land use into an impact on potentially disappeared fraction of species, so basically global species extinctions. I would like to give you a few more concrete but very brief examples on biodiversity assessment and positive impact. The first one is on LCA, and it's about a very preliminary assessment of a project in a protected area in Cuba, Cuchillas del Toa. And it compares a baseline situation with 2 scenarios. You see that the metrics that underlines this baseline situation and the scenarios is those inventory data, so just land use. In the baseline, there are some pastures in the protected areas. In a first scenario, which is the current trend, the business as usual intensification, the livestock sector is growing, and some of those pastures will be shifted to a more intensive use, and there will be also more import of external feed. And then the alternative project scenario would be more of a sustainable intensification, with, on the contrary, shifting to more extensive pasture use and again relying on imported feed, but making sure it's sustainably sourced. Those characterization factors in orange here are the methods that I mentioned before by Chowdhury, and they give you basically for each square kilometer of those different land uses and their location, the global impact on species extinction. So by just doing a multiplication of the two, basically, you can compare the potential global extinctions in the baseline and in the project scenario, and in that case, the business as usual intensification would lead to 25% more potential extinction at global scale compared to the baseline, while the project scenario, the sustainable intensification, would reduce potential species extinction by almost 50%. The second example is on soil. It's an ex-ante assessment of a very large World Bank investment in Kazakhstan using another LEAP document, the LEAP guidelines on soil organic carbon. In Kazakhstan, the situation is that the government is developing a lot the beef sector for export, and the World Bank project is there to ensure that this growth is sustainable and possibly even carbon neutral. So the LEAP document was used to model the sequestration potential under improved grazing practices. On average, this potential was 0.4 ton of carbon per hectare and per year. And knowing the projected growth of the sector, the grassland expansion, potential for adoption of improved grazing practices, we calculated basically the carbon balance of the World Bank project and showed that by only increasing efficiency, the sector would still emit 9.2 million tons of CO2 equivalent over the 5 years of the project compared to the current situation. But actually the potential for carbon sequestration is very large, 15.5%. So it would be able to offset this growth in emission. And interestingly, this potential is much, much larger than other mitigation pathways, such as the use of renewable energies, for example. The last example is on those biodiversity indicators, and it's an example in extensive livestock system in Uruguay. You see here some of the elements of the checklist. The scope was at farm level with the involvement of farmers, local NGOs, and research institutes to select indicators and define conservation priorities. Actually, among the 7 categories of indicators that I showed, only 3 were used: habitat change, wildlife conservation, and invasive exotic species. Within each of those categories, a number of indicators were selected, and those were actually combined in that example in an ecosystem integrity index that was then used by extension workers to advise farmers in their change of practices to make sure that they could also benefit biodiversity. So let me come to a few conclusions. The guidelines that I presented can support assessment of biodiversity, carbon sequestration, and other environmental criteria in the livestock sector. The positive impacts of livestock on biodiversity offer synergies between several international commitments on biodiversity, like the CBD, the UN Decade on Ecosystem Restoration that we're just entering, but also with climate commitments and several sustainable development goals. The theory, the idea, or the ideal behind this is that there are synergies between restoring land, promoting plant species richness and grassland biodiversity in general, boosting biomass productivity, putting carbon back in the soil, with also co-benefits for livestock productivity itself. But in practice, I think we need more quantitative assessments to have evidence on synergies between all those aspects and to reveal the practices that can promote those synergies in different contexts. Thank you very much for your attention.